Hi guys, In this video, we shall continue our discussion on measures of central tendency, and we shall discuss how to calculate median value of not only simple numbers but also for opinions like good, bad, or poor. But first off, what is a median? Well, the median is the value that sits right in the middle once the data is arranged in order. That's important. The data has to be arranged in order. At the median, half the data values are at or below it, and half are at or above it. This makes the median a very stable measure of the center, especially when a data set contains extremely large or small values, or as we call them, outliers. Here's our first example. These are the salaries of 7 people. Because we have an odd number of values, we simply put them in order and pick the one right in the center. Now, being an odd number, that matters because there's only one value sitting in the center. Now we must determine the middle position at which the median exists. Even though we have picked the middle value, I still want to give you a formula that works nearly all the time. So to compute the median position, we use the formula n plus 1 over 2, where n is the number of data points. For example, here n equals 7 because we have 7 numbers. You can pause the video and count for yourself. So we substitute n equals 7 and we get the median position of 4, which is what we had suspected if we looked right into the middle of the data. Therefore, in the sorted list of data, median is at position number 4. So count to the 4th position in the sorted list and we get the median or the median value to be equal to 47. So the median salary is £47,000 because the data was given in thousands of pounds. Notice one thing, that the number of data points was an odd number, that is 7. Does this formula work if the total number is even instead? And if not, what do we do then? Let's see that. In this second example, we have an even number of salaries, that is 6 salaries. So again, we compute the median position. We substitute n equals 6. And the median position turns out to be 3.5. But what is the 3.5th position? Well, we can find the 3rd position and we can find the next higher position, which is the 4th position. But there's no 3.5th position. So what can we do? Well, here's an idea. Use them both. So we get the 3rd and the 4th values out, which are 45 and 50. But now what? 2 median values? No. The median is the average of these 2 values instead. So that means we add the 2 values and divide the result by 2. And so the median turns out to be 47.5. Now notice this median value of 47.5 does not even belong in the original data. Yet it serves the purpose of the median. That is, it splits the data into 2 halves. If you space out this data and substitute the value 47.5 smack in the middle of the data, there will be 3 data points that will be below it and 3 data points that will be above it. So remember, if the median position turns out to be a decimal number, consider 2 positions. Here's another even size data set. So the total number of data points equals 8. So first of all, we order it as before. Remember, we must order the data before we compute the median value. Then we work out the median position by substituting n equals 8. And it turns out that the formula spits out a fractional value, which is 4.5. So the median position is thus between 4 and 5. So we consider both the 4th and the 5th positions, where we find the values of 35 and 36. To find the median value, we calculate the average value by adding the 2 and dividing by 2. And so the median mark equals 35.5, for the given data set. Just for practice, here's another example, but this time with odd size data set. So there are 7 points, which is an odd number of points. So work out the median position by computing n plus 1 over 2. So substitute in n, which is 7, and we get the answer 4. There's no fractional part to 4, so that makes it easy. The median position is number 4, and the median sits at that position, so the median value is 35. So the median mark is 35. An important point to note before we move further, that median value is unaffected by outliers. For example, if you change the biggest value in this data set from 41 to 1 million, the median is still 35. And I leave that as an exercise for you to verify it yourselves. So this is why median is often, seen as a robust measure of central tendency. Now here's an interesting question. Can we compute median of categorical data? For example, if there are no numbers, but instead if the marks are rated as good, bad, or poor. The answer is yes, if it makes sense to order that data. For example, we can assume that poor is the worst category, then comes bad, and then comes good. So let's order the data set now in that way. And we now have a sorted list of data. Now we can repeat the same old process of measuring the median value. So median position again can be computed by calculating n plus 1 over 2, where n equals 7, and hence the median position turns out to be 4. So the median sits at the 4th position in the sorted list, and the median position I had already made it bold and had underlined it, so you can easily spot it. Yeah, so the value bad is the median value for this data set. Hence, the median mark has been categorized as bad. So one parting terminology alert. If categorical data can be sorted, it is called ordinal data. Remember, not all categorical data can be sorted. For example, you can't sort a list of colors, because how can you say yellow is bigger than blue or better than blue? If it's a matter of your taste, yes, perhaps you can define an order, and yeah, that's fine. Maybe that works for you, and then you may call it an ordinal data. But remember, not everyone else will agree. So that's it, and see you in the next video.